All right, so let's go ahead and take a look at this problem first. So this person took 5 classes. The first class, it was a 3-unit class. She got an A, so it's kind of like having 3 little A's there. The next class, she also got an A, but it's for 4 units, so this is like 4 little tiny A's. Right, and this one over here, she got a B, 3 units, it's like having 3 little B's. And then here it's a C, so it's like having 3 little C's. And then they got an F. 1 credit though, so it's only like 1 little F. So if you do it as a table, it might be the easiest. You have an A, which is worth 4 points. You have another A, which is worth 4 points. Oh, sorry, the first one is worth, so these are your grades. And then you'll have the units. So the first A, there were only 3 of them. It's only a 3-unit class. The next one counts for more because it's a 4-unit class. The next one, she got a B, which is worth 3, and it happens to be a 3-unit class. The next one, she got a C, which is worth 2 points, and it's a 3-unit class, so it's like having 3 of them. And the last one, she got an F, which is worth 0 points, and there was 1 of those. Then you find the grade point times the unit. So this ends up being 12, 16, 9, 6, and 0. You add those up, and you get 343. So then you have 43 grade units, grade times units. What do I want? The average grade or the average unit? The average grade, they're grade point average. The average grade points, these are grade points. So it means I need to divide by units. Somehow I need to get units underneath here so those can cancel out. So I total up the units, and I get 14. So I'm going to divide by 14 units. That way, the units cancel out, I'm left with just grades. Make sense? So then she ended up getting, what was that? 3.07. That's her GPA. So you can limit it as 3.07 because typically grade points, we usually have those as 2 decimal places. Or, since the general rounding rule is that you have 1 more decimal place than your data is in, you could round it to 3.1. Either one of those are okay. Good. You guys want 30 seconds with your neighbors?
Yes.
Okay, take 30 seconds with your neighbors. And get your calculators out. And up.
Create, but I've done them out. Yeah. You're not done? Finish it. Because they're really helpful. Especially for the homework. You really need it.
So next, your homework. Okay, so here it is prettier. Your homework that's due on Thursday So I know I said skip this problem, but we're going to go ahead and do it using the calculator, because I think that'll be a good use of it. So everybody pull up your TI 83 or 84 calculator. It is right here, so if you're not sure, it's this little calculator with a little white rabbit next to it. Turn it on. This clears it. And we want to go to, everybody have it up? Go to Stat. And then edits the first one. So hit Enter. Get it up. If you want to clear the list, you have to go up so that you're actually on the L1. See how the black cursor is actually on the L1? Here it isn't. Here it's on the 22. Everybody see that? Go up so it's actually on the L1 and then hit Clear, Enter, and it'll clear it. Go ahead and put the data into list 1, so that's 22. And if you're using the computer, you can just put it right in on the keyboard using these keys on the side. And just hit Enter and it'll go down to the next one. So 22, Enter, 22, Enter, was it 26? Oh, see I made a mistake, you got to arrow back up and go back up there. 22, Enter, 26, was it 23 or 24? What was that? Oh. All right, so we are in our notes, chapter 3, and if you go to the 4th page, in the very middle, so last class's chapter 3 notes, get them out. Page 4, smack up in the middle, there's this lab problem. I told you guys to write skip on there. We're going to go ahead and do it with the calculator.
Oh, the skip one.
So one says skip on it. I told you guys to write skip on it. We're going to do it with the calculator. Does anybody need a chapter 3 notes? Everybody has their chapter 3 notes? Okay. So go ahead and type in the data for these problems into that list. Stat, edit. So click the stat button, which is right kind of in the middle, kind of right by where all the little arrows are on the side. So hit this stat button here, and then edit the very first one. Right, so stat, and then the very first one's edit. You can either hit 1, because that's the edit, or hit enter, because it's on edit. And then go ahead and type them all in. What is it, 23 or 24 next?
26.
24.
24 and then 23? Okay. Everybody have them all in? Okay, once they're all in, Rob, you got them in yet? Okay. Then everybody have them all in, you hit stat, and then go to calc. Hit the right arrow over to calc. You want the very first one, 1 bar stats. So you can either hit 1 or hit enter because it's on it. If I hit 1, since it's number 1, it'll take me there. And then in the 83s and the basic 84s, since we want everything in list 1, we can just hit enter there. That's the simplest thing. If you have a fancy 84, it will give you something else. It'll say list with a colon, and you want L1 in that one, and it'll say frequency, and then you leave that blank, and just go down to calculate. Yeah. Stat. Stat. Go to calc. Arrow to calc. Arrow to calc.
But I'm supposed to know now.
So if you don't have anything in, if you have, if that's blank.
If you know you're going to use L2 or 3, but you don't have it. It won't mess up your
Let's
data.
get there a second. So If it happens to be, for some reason you need to put L1 in there, like if yours is blank, it just says list. The way you get to L1 is, see how L1's in blue here? If you hit the blue key second, and then you hit that, then L1 will pop in here. You guys see how L1's in there? If I want L2, see how L2's in blue? If I hit second L2, then L2 pops in there. But I don't want those, so I'm going to clear those out.
So I'm sorry, say that again. If you need it, you hit the second and then L1, and then that does
Second
what?
L1 and L1 should pop in.
Oh, got it. Okay.
Should pop in wherever your cursor is. L1 should go there.
Understood.
Yeah. Is everybody have this up? Thankfully, you got yours. So everybody should have this. Oh, leave that. Leave that. So you want your frequency to be clear. Have the fancy one. You want frequency to have nothing in it. Delete it or clear it. Clear it.
And then just like calculate. No.
All right.
This does again. And then put one.
Someone asked, what's 2-bar stats? 2-bar stats is when you have an X and a Y, which we're not going to get to until chapter 10. When you have two variables, an X variable and a Y variable. Right now we only have chocolate chip cookies. If we had chocolate chip cookies and calories, then we'd have two variables. Right? But right now we only have one variable. Okay, so let's take a look at what these things are that we have. So we have X bar. Everybody see that? What's X bar?
23.4.
But what's it stand for? Our sample mean. So our sample mean is 23.4. You guys, I need eyes here, guys. Everybody, eyes over here. Okay. And then we have the sum of our x's. That's when you add up all the x's. If you add them all up, that's what you get. And then we have the sum of our x's squared. If you squared all your x's first and then added them, that's what you get there. And then see where it says Sx? And then below that it says sigma x. You guys see those two? Sx is our sample standard deviation. Sigma x is our population standard deviation. It gave me both. Oh no. Here's the thing. The calculator doesn't know whether you gave it the whole population or whether you gave it a sample. Right? It could be that those numbers are the whole population. It doesn't know, so it gave you both. You know, you're the smart one, you know whether you gave it a population or a sample. In this case, what was it? What are these? Talk to your neighbors, 15 seconds. Is this a sample or the whole population? So what is it, guys? This is a sample. So because we gave it a sample, Armida, you guys with me? Because we gave it a sample, then Sx is the one you want. Sigma x is really meaningless. Does that make sense? Because you gave it a sample. So the Sx is the one that has meaning. Angel, do you have another question?
Yeah, so does sample mean in the population mean? Yeah, no, standard deviation.
Sample standard deviation and the sample mean?
Is the sample standard deviation, the population standard deviation. Are they different because
Yes.
one is subtracted by
Okay, so
5 and the other
see how those are not the same number?
is divided? Yeah.
Do you guys see that? That's because, remember, if it's the whole population, we take all the differences, we square them, and then we average them. We add them up to by how many there are. That's our sample variance. But when it's a sample, that's our population variance. But when it's a sample, our numbers are going to be off a little bit, so we need to make that a little bit larger. So instead of, we sort of average them, we add them up, but then instead of dividing by n, we divide by n minus 1 to make it a little bit bigger. Do you guys remember that talk I had about the $20 divided by 5 people? Right? It's a little bit more if you divide it by 4 people. So when it's a sample, because our data is not quite right, our mean's not quite right, everything else is not quite, it's all off a little bit, off of the true population, then for the sample standard deviation, instead of dividing by n, we divide by n minus 1. So that's why you can see the Sx is a little bit larger than the sigma x. Because it's saying, oh, this is a sample, it's bound to be off a little bit, so we're going to make it a little bit bigger.
Thank
Yeah.
you.
Does that make sense for folks? So that's a really good question. We'll go back. I can show you what I mean here too.
And then typically, like, for that one, we're using the sample, like, it's in 1.6733, so would we just write it as 1.67, or would we?
Yeah, 1.67. One more decimal place than whatever your original data is in. Right, so this is our sample. It's divided by n minus 1. If you look at your notes, on, I think, page 3, maybe? Right? You have your population, variance and standard deviation above, and below that you have the sample variance and standard deviation below it. And the only difference between these guys really is that this one's divided by n minus 1, this one's just divided by n. In this class, I'm going to talk about that next, so I'm not going to talk about that now. Oh, no, it is in this class, I guess. I thought I would talk about it. Huh, really? Where's the part where I ask you guys about? No. All right. Right. So. So again, we have our population. I swear we did this. Oh, wait, I can do it later. Okay, no worries. So what do you guys end up with? You ended up with an S of, what was it, S? 1.67. Okay, that should show you one more decimal place than your original data is in, so I would say 1.7. So my original data has no decimal places. So, I mean, it's actually be 1.7.
1.7?
Yeah, because my original data has no decimal places, so my standard deviation should have one more than my original data is in. Now, if someone asks what the variance is, so say your homework says, what's the variance? How do I find the variance? The calculator didn't give you the variance. How would I find that? You square it. Remember, variance is the square of this. So if S is 1.7, or 1.67, then S squared would be 1.67 squared, right? So you find that, and then you round it off to one decimal place. Yes? Good? Do I need to do it? Should I do it? 1.67 squared. That's equal to 2.79, 2.8. And this is S. This is your standard deviation. Standard deviation is roughly on average how far your value is away from the mean. And this is your variance, which has no real value, I don't think, except for it's the square of the standard deviation. I mean, and people ask you for that sometimes. Okay. Let's move on. Okay, so the range rule of thumb. This is based upon, why am I reading? Vanessa, read.
Range rule of thumb for understanding standard deviation. It is based on the principle that for many data sets, the vast majority, such as 95% of sample values, lie within 2 standard deviations of the mean.
Yep. That means most of your data lies within 2 standard deviations of the mean. So the last problem, our mean was 24.0. Is that right? Yes? Our standard deviation was 2.6. So if our x bar is 24.0 and our s is oh, our S was 1.7, then that means that if I go jump one standard deviation this way, and another one, jump two of them, I add 1.7 twice, I will end up where? 24.0 plus 1.7 is 25.7, plus another 1.7 is 27.4. And then let me jump backwards. Two standard deviations, so this way, and two standard deviations this way. Minus 1.7, minus 1.7. Let's see, here I'd get to 22.3, and here I'd get to 20 point, is that wrong? 20.6. Then that means that from here to here, this is within two standard deviations of the mean. From 20.6 to 27.4, roughly 95% of chocolate chips of all cookies will have that many chocolate chips in them. Or the vast majority. So roughly, most of them will be between those two numbers. So you're roughly 95%. So let me ask you this. What's our guideline for unusual? 5% or less. So 5% is unusual, 5% or less is unusual, then the usual values will be that inside 95%. Does that make sense? 5% is unusual, 95% would be the usual numbers. So roughly 95%, if it's normal, will fall within two standard deviations. Within two, let's see if you guys are having trouble with that. Who's ever been to a fair before? County fair, state fair? And you have those guys who say, I will guess your age within 3 years. If they guess 30, what do they get? What, for valid ages for you to win? 27 to 33. 30, they get 3. Within 3 means they get 3 this way, they get 3 that way. Within 3, right? They get 3 this way, they get 3 that way. So that's the thing. Within 2, standard deviations mean I get 2 this way and 2 that way. So you start with the mean, and you go 2 standard deviations this way, 2 standard deviations that way. From here to here, those are your usual values. Make sense? Here's the kind of the formula for that. But I would say what you really want to make sure you do, if you're going to do this, is find 2 standard deviations first, and then add and subtract them. Because this is what people do when they see this, that they use this formula. Is they take the mean, they subtract 2, and then they divide, and then they multiply by standard deviations. Then they get some crazy stuff. So if you have a mean of 24.0, they'll end up with something like this. They'll end up with, oh, well, the typical usual values of chocolate chips are between 30 and 60. That doesn't even include the mean. Do you guys see what I'm saying? So if you get any data and you have usual values, it should always include the mean. First of all, the mean should always be between your minimum and your maximum. Is that, are you kind of following that? If you take the average height should be whoever the shortest person is and the tallest person is. The average height better be between them. It shouldn't be above that. Is that you guys see what I'm saying? So pay attention to things like that, because a lot of times you guys will just get stuck in your numbers and you'll come with this crazy number that doesn't make any sense at all. Right? The other thing, like I said, is your minimum and maximum usual values should include the mean. The mean should be in the middle of that, smack dab in the middle of that, frankly. So I would recommend, like I said, find 2 standard deviations first and then add or subtract that from the mean. So this one, I'm going to skip this one. I'm not even going to worry about it. We'll skip that one, because that just confuses people. I don't think it's important. So what you guys do this example on your sheet. We're not here. We're here. Right, we just did this part here. So we are doing just this stuff. It's top page 5. Top page 5.